Okay, so let's start. In this demo, we're going to see two different solutions, the integration with Peakflow and the two-tier mitigation. So basically, let's have small agenda regarding our lab. Defenseflow can detect attacks from NetFlow statistics, from SmartTap, which is a port mirror technology. We can use inline devices, which we will use in this case. This is the two-tier mitigation, and any external source like Arbor or Peakflow, which will signal. So we're going to use the inline and the external scenario here in this lab today. Regarding the diversion plan, we're going to send BGP advertisements to the border routers to divert the traffic towards the scrubbing center. And the clean traffic will be leaked back using VRF leaking. I am going to show you later on. The mitigation devices on the scrubbing centers are the HTX 420 units. So let's have a look at a short diagram regarding the concept of two-tier mitigation, so you will understand what is the concept of this protection. So if the attack will start from the internet towards the protected object, the first line of defense will be the inline device, of course, the customer premises device, and it will start the mitigation immediately. If the attack will increase and the traffic will bypass the threshold that we were defined before, this device will signal the defense flow that the threshold is breached and that the traffic should be diverted because we may have a pipe saturations here on the premises. Defenseflow will export the policy which is mitigating the current attack towards the scrubbing center, and then it will divert the traffic using BGP. So it will prevent a pipe saturation and a possible damage to the CPE device because of the high amount of packets. Any questions regarding the two-tier mitigation scenario?
No, thank you. Continue, please.
Okay. Regarding the Peakflow integration, the Peakflow will gather NetFlow statistics from the border routers, and when the attack will start, Peakflow is going to detect the attack and will send the syslog to Defenseflow. Defenseflow will parse the syslog to relate it to the protected object, and will do basically the same. It will export a policy to Defensepro, to the mitigation device, and will divert the traffic. Any questions regarding the Peakflow integration concept?
No.
Okay, great. This environment will run some legitimate traffic just so we won't have, like empty interfaces. So we're running HTTP traffic and some DNS queries. The attack will be made using fragmented floods, CMP fragmented Syn Flood, so it will be a heavier and more complex attacks. Regarding the protected networks, this protected network will be discovered by the external detector, which is the Peakflow. And the second protected network will be discovered by the two-tier mitigation device. So we will attack two different objects to demonstrate two different scenarios. Let's have a look at the lab topology so you will have an idea of how the traffic will really flow here in the environment. So in this lab, we're going to use two scrubbing centers. Each scrubbing center is directly connected to a border router. On the right, we have the second scrubbing center, which is connected to the SR9K. The traffic will be diverted to the scrubbing center and will be leaked through clean VRF to the PE router. Same are going to happen here. The traffic will be diverted to the Defensepro and will be leaked back via clean VRF. The usual traffic flows from the clients here through the borders and the P router to the servers here. This is the traffic generated by Spirent. We have a Windows server here, so we can work with it to see how the server is. We can ping it to see what will happen. On the management plane, we have the external detector, which is the Peakflow. It's on the same management network, of course, with the Vision and Defenseflow, and we have the inline device. So this one is responsible for the first object, and this one is responsible for the second object. The attacks will be made from the Backtrack Linux virtual appliance, and we are going to attack this server here, which resides in the same scope of the protected objects. Any questions regarding the topology of the lab?
No, sir.
Okay, thank you. So let's see the configuration of the router first. So let's go to the SR. So basically, we have the routes on the border router towards the protected networks. And we have the same routes leaked from the global to the VRF. As you can see, the same routes are represented in the VRF and the next hop in default. So basically, when the packet will reach the clean VRF, it will be exported to the next router on the VRF default, which was not affected by the diversion path. Regarding NetFlow, this router exports NetFlow statistics to the Peakflow, as you can see here, and this is the IP address of the Peakflow. So when we will attack the object, the attack is going to pass through this device, and of course, Arbor will get the sample statistics. Let's open the Linux device. This is the backtrack. And as you can see, we have the path from the backtrack towards the protected object. So we have the ops of the border router and of the PE router. Let me bring it here, like this. Okay, so basically this is the Linux backtrack, and we reached 10.2.20.1 to 20.1 is the SR9K, and 10.2.30.9 was the Juniper MX18, the PE router. This device does not support the record flag of in the ping, so it will not appear. It's not a simple trace, so basically it's invisible here. So the next hop we can see is the Windows server itself. And this is the way from the Windows server back to the backtrack. So we have 10.2.20.2, which is this interface, and 179.12.254.254, which is the uplink of the border router here. So we have a symmetrical route towards the protected object and back. Of course, this path is going to change when the diversion will be active. Okay, so let's have a quick overview of the Defenseflow itself. So let's just go menu by menu, so you will have a basic understanding. The first window in the configuration is the licensing itself. Here we have the IP management. We basically should have two different network access. The control network access, as you can see, uses the ASR as the default gateway. This one is made for the BGP advertisements, so we must have an interface in the data plane. So this interface will be used to advertise the diversion path. And the second interface is in the management pane. It's used to communicate with the Defensepro devices. We're using this interface to communicate with the management interface of Peakflow. So basically, we should have a control plane and the data plane in the Defenseflow. In the network, we have the basic BGP settings, the router ID, the local AS. And here are the control elements. Control elements are the detection sources used here. So we have a third-party detector, which is the Arbor. I'm going to reach Arbor after this, so you can see the settings we did there. The second control is the Radware network controller. The network elements are the routers in the lab. So we have the SR, which is the 9K right border. We have the left border, which is the MX18, and the P router. Of course, each one of the routers here use BGP peering with the Defenseflow. So you can see here on the router, we have the loopback of the SR, we have our router ID. We're using iBGP session, timers, some capabilities. The settings are pretty straightforward. I can group the network elements, so like I did here in the borders, for example. So when I will advertise something to borders, it will be advertised to the both border routers. So this is just, for better management. Here is the mitigation devices menu. So I have all my Defensepro here. Each one is represents a different scrubbing center, and this one is the inline device. So again, the settings are pretty straightforward. The settings are automatically added when the Defenseflow is added to the vision device. So all I need to specify here is as you can see, the version IP address. So what next hop will be advertised so the attack will reach this specific Defensepro. Again, I can group the devices same as I did here with the network elements. Any questions regarding the network menu? Okay, so let's proceed with the security settings. Here I have the detection sources. So all the detection sources of Defenseflow will be aggregated in this window. I have the DDoS detection, which is irrelevant for this demo, but it uses our NetFlow collection here. So the DDoS detection uses Radware collector. I have external detection, which uses the Peakflow. Here I have the inline detection, which is my Defensepro CPE device. And my detection is a predefined setting, so I can just get rid of it. Regarding the workflows, here are some predefined workflows, and the workflows we're going to use the external detector and the delegation. So let's see the external detector workflow. The detection will be made by external detector, which is Peakflow. And then we have a pretty basic function, like you can see here. If the attack will start, I will use this operation, and we're going to see what this operation means. Of course, I will end using this operation when the attack will be terminated. So you can define many criteria in one workflow. Each criteria may represent attack start, traffic, packets per second threshold. I can play with the attack criteria, and I can use different criteria to lead to different actions here. Same with the out of path, as you can see, I can use attack destination towards this network will use this operation, and attack destination to every other network will use this operation. So this is very flexible, and I can just predefine the scenarios of what will happen in each case. Regarding the operations, again, this is the operation itself. These operations are bound to workflows.
So I'm going to interrupt just a bit to do some comments about the customer. Just for you to know, those operations actually are the ones that we are going to be able to configure for each country. So for example, if we have Defenseflow in Miami and we have different countries, actually we can handle the traffic for each single country on a different way. And that's the way how we do it. I mean, and of course we can take different actions depending on that traffic. So it's going to be really specific about what we are going to do with the specific traffic, for example, from Curacao or from Colombia or from any Central America country or island. Sorry, Sergey.
No problem. So just as has been explained right now, this action will lead to mitigation on the third scrubbing center, and then out of path will be mitigated by the second scrubbing center. So I can define what will happen where. So basically, if I will enter here, I will advertise the diversion to this router, and the mitigation will be done on this Defensepro. So I can pretty much predefine what will happen and where it will happen. Of course, I can use a different action prior to start the mitigation of the protected network, and we are going to see this here. These are the protected objects themselves. So each object represents a different use case. Our object 102, as I said before, represents the Peakflow. Each is the external detector scenario, and this object is for the delegation from the CPE, which is the two-tier mitigation. So if we're going to see this one, this object monitors this subnet. The action mode is user confirmation, so it won't do anything automatically. It will ask me to confirm that the action is correct. Of course, I can define automatic action or manual action for always-on objects or objects that can be automated freely. But if I have some sensitive traffic, I would prefer to confirm. Security settings. I need to define the peak bandwidth. The bandwidth this customer usually uses. Again, it can be provided from NetFlow statistics. And I need to bind this object to a workflow. So this object will be bound to the external detector workflow. I can, of course, define manual thresholds that will work together with the detector, but these thresholds are only usable when I'm aware of the traffic. So I'm not aware of the traffic here because the Peakflow is the one who's doing the detection. So basically, these thresholds are defined in the Peakflow itself. Any advanced settings like BGP community, some basic BGP, some well-known communities, I can just paint the advertisement with community to prefer it over other routes. So this machine supports full BGP, so pretty flexible here. Regarding the monitors, here is the pending actions. So when the object will be triggered, the confirmation will jump here. So we're going to see here the confirmations. The mitigation devices will be monitored here. Because it's a demo lab, I just disabled the health check because the objects are here near me. I don't really need this feature, but you can monitor the objects using the CPU, the bandwidth of each object, and the device may be aware if he should or should not divert the traffic to a specific scrubbing center because it may be already busy doing something. So this window here will help to understand this better. And this is the current state of the protected objects. So no one of them is attacked. 2 of them are being provisioned, and we are going to get here. And of course, each object is a different scenario. So regarding the provisions here, you can see it here. We're provisioning 2 objects. The provisioning is the policy installed on the Defensepro for detection. So this object in this network is being provisioned on the customer premises. So if I will enter this device here to its settings, I can see the policy that was exported by Defenseflow. So if I will disable the object on Defenseflow, this policy will be deleted from Defensepro. This policy will be used for detection. And I don't need to create them manually. It's automatically created by Defenseflow once the object is activated. And the BGP monitoring settings. All peers are. Yes?
The last one slide with the Defensepro configuration, is that the inline Defensepro?
This one is the inline. The okay. 104 is the inline. Here is the CPE. Yeah. So because the inline Defensepro is manageable, it can be manageable, it cannot be manageable. In this case, I want to manage it because I need to delegate the policy. So the second I activated the protected object on Defenseflow, this policy here is on the CPE device. This is the inline device.
Okay.
So basically, when the attack will hit this device, this policy is going to protect the device. If the traffic, the packets per second will reach the predefined threshold, this policy is going to be exported from here to a scrubbing center, and the traffic will be diverted there. It is going to use the same policy.
In the big Defensepro out of path.
Exactly.
Okay, thank you.
Regarding the BGP monitoring settings are established, no announcements correctly, and flow spec address family, which is not relevant currently for these scenarios, but it is here. And security monitoring, we will be able to see the attacks here, and the attacks will come from Defensepros and from Defenseflow itself, so we can see the source type, a different view on the same information. You can see it here like a dashboard, or you can see it here as a table. Or traffic monitoring. So basically, I can monitor traffic per object or all objects together. and protection monitoring, which is related to DDoS of Defenseflow. So in case of external detection, this setting won't be relevant, but if I'm using the detection of Defenseflow, of course, this is the behavioral detection window, which can detect and objects which are monitored, like this one, which is monitored by Defenseflow itself and not by Peakflow. So I have sampling statistics. I can see the baselines that are automatically created. So now I have some drop in the UDP traffic of this device, but as you can see, it's on the green baseline. It's on the normal edge. So the same technology used in Defensepro used here. Any questions regarding the menu? Should I expand on any menu? Okay. So this is the Peakflow, and as I told you, it uses the same management address as the Defenseflow. So they are on the same management network. So basically, this is time out. Okay, so this is the protected network, protected by Peakflow. Let's see, we're matching this network, the 102. And some thresholds, so pretty much straightforward configuration here. Of course, I have notification settings here, so I have the rules. So if any attack will occur on this object, I will syslog Defenseflow. So you can see it here in groups. I will syslog this device here, and this is the same IP in the same management network, which can be found in the IP management configuration here. So basically, syslog will be sent from Peakflow to Defenseflow when the attack will be discovered by Peakflow. Okay, so let's bring back the backtrack. And let's start a fragmented attack towards the object that is monitored by Peakflow. So I've started a fragmented flood. So basically, I should have the flood here anytime now. So let's give him a minute to show us the flood. In the meanwhile, I will open the window of Defenseflow to show you the syslog arrives there. Okay, so let's refresh this one to see if anything changed here. Okay, so I have fast flood. And this is the CLI of Defenseflow. So I'm just monitoring the DFC syslog incoming file with the pipe grep on the IP of Peakflow. So as you can see, Peakflow already sent me that this is a fragmentation TCP SYN attack with some information, and I have the host. So what Defenseflow needs to do now is to relate these hosts and this attack to a protected object. So back to Defenseflow, I should have now see that this PO is being attacked because the external detector told us so, and we need to confirm. So if I'm going here to the pending action, you can see that Peakflow told us the attack ID is 1000. As you can see, it's the same attack ID here. So this attack is now represented in Defenseflow. Basically, I can double click it and I need to confirm the start. So it supplied me the traffic. I can divert the whole network or I can divert the IP. Of course, I get the IP from Peakflow. I can use community or if I need to. Of course, it can be predefined from the PO itself because I define no community, this field is empty, and I can divert a full network just to show you how we see it in Defenseflow. Of course, I can decide to use a different scenario prior diverting. So in case of one scrubbing center is now fully operated, I can divert to another scrubbing center. So let's use the default here. I will just submit this one. And this device is going to import a policy to a scrubbing center here. So for now, this one is empty. And every second, okay, as you can see, I refresh the page and the policy is already here. And this policy is for the protected network that was discovered by Peakflow. So the policy is here. All the profiles are already here. The class, again, as you can see, the class is the same network and the mask as was represented in the Defenseflow. And let's go to Defenseflow back, and we just need to validate that we have two announcements of this network towards the scrubbing center. This 10.2.10.2, as you can see, is the next hop in the VRF clean, because this scrubbing center is transparent. It doesn't use IP address on it. So basically, this interface of ASR is directly connected to the interface in the clean VRF. So the next hop is the clean VRF via the Defensepro. So Defensepro already detected an ongoing attack, and it's a fragmented TCP flood. And we can see that we have a very strict footprint. We have the destination IP, we have a fragmented AD, we have the TTL, we have two variable packet sizes. Of course, this signature uses a ball and ends, so it can be a false positive. Yes?
Just a question. You're not using the HT in IP mode. You're using it in transparent.
This one in IP, the other one is in, I'm sorry, this one is transparent and the other one is in IP mode. I am going to show you both of them.
Okay, just a question. If you're using it in transparent mode, can I use an ODS3 with the 6th version? Or
basically, no, you can use, because I'm using here this one as the and mitigation. It can export a policy to the ODS. It can.
Okay, so I can use ODS3 or ODS4?
By concept, yes, you can use. By concept, you can use the ODS platform as well. I did not implement this yet, but as you can see, Defenseflow is capable of managing the ODS. This one is ODS.
Yeah, DS.
So I don't see issue. Yeah, this is ODS3.
Okay.
And as you can see, Defenseflow installs the policy here. This is the two-tier mitigation scenario. So I can use this one as a scrubbing center as well, basically, because I don't need to use IP interfaces here, as I shown on the second scrubbing center. The next hop is through this Defensepro. So,
Sergey, we will have a later conversation regarding what I asked you. I don't want to interfere more in the presentation.
Okay, no problem at all. Okay, thanks. So regarding the footprint, as you can see, it should be a 100 match. So it can be false positive in such a strict footprint here. And if I'm going to the traffic monitoring, I can see that the attack started here. It's reaching the device. I have the attack age, and the gap between them is my legitimate traffic. So basically, if I'll open the Windows server here, which uses, let me just expand this window a bit. So this server is the protected Windows server I told you before. You can see the attack is not reaching this because the Wireshark is running. And if I will go to the backtrack and I will open another instance, I'm sorry, wrong button, duplicate here. And I can ping the same attacked network. My pings are here. So the attack is being fully mitigated by the Defensepro. Only the legitimate traffic can make it here. Any questions regarding the integration with Arbor?
No, we can just say wow.
Okay, so basically I am going to stop the first attack here.
David, do you have any question about it? But I mean, this is not this is one of the demos which is using Peakflow in order to take information. It's not the final purpose. We are going to see the two-tier mitigation, which is the one that we discussed on our last meeting. But this is one of the ways that we can use. I mean, we can connect to Peakflow and take the information, and of course act according to that information.
Sí, ok. Very clear, yes. Gracias.
No, con todo gusto. O sea, incluso si, ¿cuál es la idea ahí? La idea es que miremos todo o sea, este es uno, como él decía, hay muchas formas de mitigar. Lo interesante es que desde Defenseflow, como vieron ahorita, ahí es donde yo creo las políticas incluso de mis clientes, o sea, que yo voy a tener un solo punto de gestión de toda la plataforma. Y una vez yo creo las políticas, que es lo que vamos a ver en el siguiente demo, de cómo creo una política hacia el CPE, que es el escenario real que hablamos ayer, y es que yo tengo un CPE antier, perdón, que yo tengo un CPE en el país, en el cliente, donde sea, porque tengo un CPE al final, y que yo tenga mi Defenseflow ubicado en mi sitio central. Eso es lo siguiente que vamos a ver.
Okay.
Thanks, Sergey.
Okay, so I stopped the attack here, and as you can see, it's dropped, and I have only my legitimate traffic now. So basically, when Peakflow will signal Defenseflow that the attack has stopped, it should be happening anytime now, probably. We should have the pending confirmation for the attack stop, basically. So no CISO yet, because it should be on some grace period. Let's see what's going in the Peakflow itself. Let's see ongoing. Okay, so it's still ongoing. We need maybe to wait like 1 minute till it will. It already shows us a drop here. So basically, I just need to have a confirmation sent by syslog from Peakflow to me to say that the attack is over, and the Defenseflow will ask me here on the pending action if it's okay to stop the attack. Of course, if the action was sent on automatic, everything was happening without my interference. It was diverting automatically, and it would stop automatically. But I just wanted to show you the flexibility here. So the confirmation is a must here. Okay, so this one dropped. And no syslog just yet. Okay, so we will wait for the grace period. In the meanwhile, I can start another attack. So I'm going to start a fragmented Syn Flood this time towards the second protected object, which will be protected by the inline device. So let's start this one. And if I will go to the CP, as you remember, I have the policy here, which is protecting this device, the 192.168.104 network. So basically, if I'll go back, I should see the attack anytime now when it will reach the device. Let's see if anything happened to the traffic here. Okay, so I have a traffic increase, and it says that this traffic is already discarded because it's an attack traffic. So let's go back to the dashboard. And as you can see, there is a behavioral DDoS analysis which discovered an SCMP flood. And it should now tell me that it's a fragmented one. Okay, so I have an SCMP flood here. I already have a footprint which is blocking this SCMP packet. So again, variable sizes, destination IP, some frag ID, TTL, and packet ID. Again, a very strict signature. And of course, it's generated real time. So if anything will change, if the signature won't be efficient, it will try to find a new one on the fly, of course, real time. So I need to do nothing, basically. And here's some attack statistics. Yes.
If the vector attack change, the footprint is changed too, or they're gonna create a new footprint for a new attack?
It depends on the protocol of the attack. If it's on the same protocol, it will create a new. It may create a mutual footprint. You know, so I will match like ICMP and TCP, this packet size or this packet size. So in most cases, it will just attach the current footprint because it started from something and it will just get there eventually within 18 seconds.
Okay.
To show that you stop one attack and send another attack, and
yes,
it is mitigated by the scrubbing center now, not by the on-premise.
This attack was mitigated by the scrubbing center, the attack that Peakflow showed me, but now I'm launching the attack towards a different IP address, and this is a premise device. This is an ODS3 platform, as this is the CPE, as you can see. So now the attack is being handled by the premises device. If I'll bring you back the topology here, this is the premises device. I'm sorry if I didn't mention it.
I'm gonna just... En ese momento lo que estamos haciendo es tirando el ataque al equipo que estaría en las premisas del cliente o en el equipo que estaría en el borde del país, que es el CPE que está en la parte de abajo. Ese CPE, al final del día, es un Defensepro que hace Network Behavioral, que hace todo lo que ya sabemos, que Oscar les mostró previamente incluso. Él va a ir, mirar y va a detectar el ataque, pero ese es el trabajo del Defensepro. O sea, hasta ahí solo estamos mostrando lo que va a hacer el Defensepro. Ahora lo que vamos a ver es cómo funciona la parte de TUTIL, y es que basado en la configuración del Scrubbing Center, yo puedo tomar la información de ese CPE y llevarme, porque el tráfico comenzó a crecer mucho, y llevármelo al Scrubbing Center. Sorry, Sergey.
No problem. Okay, thanks. So basically now the attack is being handled by the CPE. So as we can see here, it is ongoing, it is being dropped. If I will see the traffic monitoring here, so it's like above 16 megs here of ICMP flood. If I will go to Defenseflow for 1 second to show you again the workflow. So my workflow of the delegation says that if the object is attacked, but the attack is higher than 300 megs, only then I will divert. Because if it's less than 300 megs, it can be handled by the premises device. And this is exactly what's happening now, as you can see. It is handled by the premises device. It's lower than 300 megs.
Sorry, another interruption. Esto es algo que ustedes me preguntaron hace un par de días, y es, ok, yo como defino exactamente después de qué paso envío el tráfico a la nube, y es ese paso que acabo de mostrar, Sergey. Y es, después de ancho de banda, yo sé cuánto ancho de banda puede soportar el CP del cliente y en qué momento debería enviar ese tráfico a la nube. Y es ahí donde se hace la configuración. Entonces ahí yo puedo definir si este cliente es de 100 megas, entonces al mega 120 tíralo a la nube, o si el cliente es de 1 giga, tíralo después de 2 gigas, en fin. Pero es algo que yo puedo definir en el flujo, y lo puedo definir, yo puedo crear diferentes workflows asociados a diferentes equipos. Thanks.
Okay. So we can increase the attack. So basically, what I need to do here is to stop making it, instead of faster, I will turn it into a flood, and I will just start flooding now. So this will use the whole resources of this virtual machine. So the traffic should increase. By the way, let's go back to our syslog here, and yes, I get another syslog from the Peakflow. This is regarding the old protection, which we just skipped because we didn't want to wait till it will send us. But Peakflow says that the managed object is now done, so the attack on the previous object is now over, according to Peakflow. So here you can see the drop, which I stopped, and the new attack is already here. If I'll go to Defenseflow here, I have two actions. The one is the end of the previous attack of 102 by Peakflow, so I can just confirm the end. It will warn me again that this will terminate. So no, I can't really make a mistake here, and I need to submit it. So this one will revoke the policy from the scrubbing center here. So as you can see, it's now processing the policy because I entered the device right after submitting the changes. So you can see the device is now busy removing the policy. And as you can see, the policy is not here anymore. So each policy will be added on demand on the scrubbing center, and I don't need to manage a big list of policies that are dynamically added in case of need, of course. So back to the pending actions. Now the device says that this object is under attack and it needs my diversion. As you can see, I need to delegate the policy, and that's because if I will go here to the CPE again, to the monitoring, here you can see that the traffic is now much higher. It was 60, but now it's 350, and it's above the 300 max threshold that we defined in the workflow. So basically now I have a simulation of a possible pipe saturation and a danger to the CPE device. So everything I need to do is just on Defenseflow, just to confirm that I want to divert and delegate. Of course, this is the action we created here, but I can divert and delegate the policy. So what will happen just before I'm doing let me submit, sorry. It will be diverted here. So for now, this one is empty, no policy on the first scrubbing center. The policy is only in the CPE. So basically, this is going to do like copy paste to the policy. As you can see, it's already here on the big scrubbing center. So the policy is in the CPE and it's in the scrubbing center, the same policy. So now Defenseflow will divert the traffic from the CPE to the scrubbing center. So basically the CPE should see the attack traffic no more. Let's see. It will refresh in a few seconds. I'm probably still waiting for the BGP announcement. Okay, so we have the BGP announcement for this for this peer here. And this one should have the traffic. Okay, so now the traffic reaches the scrubbing center. Going back to the CPE, the traffic is not reaching the CPE anymore. Of course, only the legitimate one will pass through the CPE. And the scrubbing center is now mitigating the attack. Let me just to show you the boost through the interface perspective. And we have network ICMP flood here. And we generated a footprint. Again, different device, same action, of course. Back to...
Can you launch?
Yes?
Can you launch another attack to see that he will detect on the other attack on the...
Yes, I understand. Yes, so let me try. I will open another window. And I will launch it towards the same source practically. So let's see what will happen here. Okay, let's see first on the CP because the first nothing here yet. Okay. Okay, so as you can see, I have ongoing DDoS ICMP, and I'm trying to start a new DDoS regarding TCP because my second attack is a fragmented syn flood, as you can see here. This is a fragmented syn flood, and the one was running already and still running is the ICMP flood. So I have two attacks. As you can see, I have a CMP, which is still here. And as I said, because these vectors are too different from each other, I generated a whole new event with a whole new signature here. As you can see, there is a different signature. It leads to the same destination, but I'm using different parameters here. So basically, this one handles the syn flood, the fragmented TCP, and this one is handling the ICMP flood. Two signatures are working now real time.
Boris, Sergey, excuse me.
No problem.
Can I make it more difficult? Is there anything that is not flat that we can see there? that, let's say, another mitigation device will never detect, but we can detect it, that you can show us?
Let me see if I have anything here.
Something interesting, you know. We need to make
it
more interesting.
Let's try. Let's duplicate this tab. Okay, let's see if I remember this. Not this one. This one. Let me remember what was the path of this attack. Just a second. I have should have it here. Defenseflow. Okay, forgot one. Okay, so let's see what's happening to this guy here. Let's clear this one to see if it's still okay. So everything is being mitigated. Of course, we've seen some noise here because I need to understand that the attack is ongoing. So we saw some few packets of attack. The one I cleared here, but now everything is silent. What I will try to do is to launch the attack towards this IP because this one diverted right now. So I will try to launch a low and slow application layer attack. So the first packets will reach it because the device the Defensepro need to understand. But basically, if I will restart it now, I think it's already stopped by Defensepro. As you can see, it's not reaching anymore the device. So we have ICMP flood, fragmented TCP Syn flood. No, yeah, fragmented TCP Syn flood and a lowest low attack. And 3 attacks are being mitigated here. And we can see the low and slow attack here. As you can see, I have intrusions occurred. So I am capable of mitigating layer 7 attack. Let's make it more interesting. This attack here is being mitigated by Defensepro, so the server is silent. If I will open another instance.
Sergey, one question. In this case, are you diverging all the BGP traffic for the whole network or just for this server?
In this case, I am diverting only this server. As you can see in the announcements, the reachability is towards the server because this was the object that was attacked.
Okay, what happens if in this case you launch a new attack for another different IP destination? Will be handled by this Defensepro in the CP in the customer?
If the customer has the policy, because it's a demo lab, I have only one policy here, but yes, of course.
Okay.
Here, practically, as you can see, I have only one policy, so it will be discovered by a different, if I will launch an attack here, for example, because here is a different network, so this device will discover it.
Okay.
So basically, this device is now working hard. And what I'm trying to do is to make wget of the same page. Wait, sorry, 104. So the Slower is attacking this one. As you can see, intrusions toward this one. And I'm trying to see if the page will respond to me. And as you can see, I'm downloaded the page from the same source of the attack of the layer 7. So I'm attacking and sending a legitimate traffic, and the scrubbing center can, as you can see, it can distinguish between them, because here is my get. I will try to do it again. And as you can see, this is my wget from the def track to this PC, and the low and slow attack is not reaching. So I have some IPS capabilities.
Let me explain this one, Sergey. Esto es muy importante porque al final del día, pues uno de nuestros mayores diferenciales es cuando hablamos de falsos positivos, generalmente lo que suelen hacer las soluciones de mitigación es que si alguien me está atacando desde ese origen, suelen bloquear todo el tráfico que viene desde ese origen. Y si ese usuario trata de entrar a la página web, pero resulta que estoy detrás de un proxy, por ejemplo, y estoy detrás de una universidad donde hay 10.000 usuarios, y hay dos que están generando ataque y los otros 9.998 usuarios quieren entrar a la página, ellos deberían ser capaces de poder ir y bajar la página. Eso es esto. Esto lo que quiere decir es que yo estoy parando el ataque, pero si un usuario desde ese mismo origen trata de alcanzar mi sitio web, lo va a poder hacer porque es un usuario legítimo con una petición completamente legítima. Este es el impacto de poder hacerlo basado en el comportamiento a poder hacerlo simplemente basado en un origen, que es lo que nosotros no hacemos. Primero. Y segundo, algo de las preguntas que hacían ahorita Arik y Javier eran, ¿qué pasa con un nuevo ataque? Como yo lo que hice fue insertar una ruta a través de BGP para que absolutamente todo el tráfico hacia la IP.1 fuera a través del Screwing Center, no hacia el CPE, pues de ahí en adelante todo el control de DDoS, por decirlo de alguna forma, lo va a tomar ese Defensepro, que es el Screwing Center. Hasta que, por supuesto, los ataques terminen y termine el threshold que he definido, que es parte de lo que vamos a ver ahora. Pero, si el ataque va hacia una, por ejemplo, a la 104.2, la cual no se está reenviando al Defensepro del Screwing Center, pues lógicamente desde el punto de vista de routing, el tráfico va a seguir fluyendo hacia el cliente, pero en el cliente está el otro Defensepro. El otro Defensepro va a poder mirarlo, va a poder analizarlo, si tiene una política va a decir, hey, me están atacando, el volumen creció. Es exactamente lo mismo que acabamos de ver para este caso. Claro, yo puedo desviar toda la barra 24, la barra 32, como yo quiera definir el objeto. El objeto es básicamente lo que yo defina para ese cliente. Thanks, Sergio.
Y otra cosa que yo quería, bueno, aumentar a lo que estás diciendo, Tobias, puede ser que repitiendo lo que estás diciendo, es nuestra capacidad con la misma diversión de detectar ataques que no son solamente ataques de DDoS, también ataques de intrusión y otros tipos de ataques que normalmente vienen escondidos bajo un ataque de denegación de servicio que está mascarando en realidad las otras cosas que están tratando de hacer.
Comenzando por un escaneo de puertos.
Y eso es algo muy importante, pues hablamos hace un par de días, es ¿y qué pasa? O sea, en el otro lado yo cubro el tema de capa 4 porque es analítico, etcétera, pero ¿qué pasa si me atacan a nivel de capa 7? ¿Y qué pasa incluso si me atacan a nivel de capa 7 mientras estoy en el Screwing Center? La respuesta es, ya lo vieron, pues igual, el nivel de protección hasta capa 7 se puede mover desde el CPE hasta el Screwing Center y viceversa. ¿Tienen alguna pregunta al respecto?
No, todavía.
Gracias. Thanks, Sergio.
Okay, so I can stop the attacks here. So everything should be stopped.
Es unas capacidades que ni Arbor, ni Fortinet, ni cualquier otro que está en este rubro puede hacer.
Okay, let's see. This is the scrubbing center. And again, as I said, this one is in IP mode. This one is transparent. This one is IP mode. Sorry, selected multiple. So this one, as you can see, the attack is stopping here. So I should receive the confirmation anytime soon because it has a grace period of its own. So basically, when the external detector discovered the attack, I diverted it to the transparent scrubbing center. And when the CP device told us that the threshold was breached, I diverted it to the scrubbing center. So basically now the traffic will pass through the scrubbing center and will go here. And of course it will reach the CP again. So just in case if the scrubbing center missed anything, it failed to mitigate the whole attack, some of the attack leaked, I still have this line. It will protect me again. Because now I have two defense pros inspecting the attack. This one is the first tier, and the CP device that inspects the traffic as well. If I will look to
the road?
Yes, exactly. Yeah. Just a sec, let's go to the SR. Cisco is more friendly, I guess. So now I'm on the right border. I'm here. So basically the traffic from this border will reach this border and only then goes to the diversion. So As you can see, I have the diversion path here. So these are the basic routes and the host route of the diversion, 10.1.10.2. If I will open this one here, so as you can see, 10.1.10, this is 0.1, this is 0.2. I can be even more specific, and I can show you it here on the configuration, network, IP management. So this is my interface. This is my dirty interface, this is my clean interface. So I am the diversion path. And if I will monitor it from the backtrack, so I can go do the same thing with the record option. As you can see, I'm going 10.1.10.1. Let's do it like this, side by side, to see the path. Okay, so 10.1.10.1 is this interface. Then I have 10.1.30 is this interface. Then I have 10.2.30 is this interface. Again, I don't see the Defensepro here because it does not support the record flag. It's not a trace, it's a ping. So the Defensepro is invisible here. So I can see this.
Your recommendation is go to transparent mode and not in IP mode?
In case, I think yes, because this IP mode adds an additional hop, while this one is transparent. So maybe it may cause some latencies. I have more flexibility regarding the routing when you will be 100% responsible to the routing. Here I need to know my next hop, and then I need to link it from here. While the Defensepro is a wire, it's a wire. You decide where it will go. So you can have full control of the diversion plan. From my perspective, it's better.
But it will depend on the topology, Eric, because if you are using VRF like this, it's gonna work just fine. But if you are using something else, for example, in Columbus, they don't use VRF because they don't have any MPLS on that side.
But you can use GRE tunnels.
Yeah, GRE. Actually, that's the one that we are discussing with the customers. We are thinking about GRE tunnels or communities.
And you don't have to use GRE tunnels from the Defensepro. I can source the GRE here from the clean VRF. I still can manage to do it on the router again. So as you can see, it can be transparent and can be IP mode. I just wanted to show you that it's flexible, and you are the one who will decide it. You can do the both.
In my point of view, I prefer transparent and make Cisco do the routing. They're specialized in routing.
Exactly. Let the routers do the routing. You know, this is my recommendation, but as you can see, I can do both, in case of need, of course. So basically, this is the diversion path, and the path back did not change because it's only an incoming traffic. So the attack should be stopped for a few minutes already, so I can see the confirmation to end the attack because the floods have been stopped. So I can just confirm the end of the attack.
And one more comment, un comentario. Muestra las acciones pendientes y showing the pending action because we configure user information. Is select automatic is going to be done by the system itself.
Sergey,
yes?
Can you show it to us one more time and put the policy on automatic to see how you launch the attack and everything behaves automatically, all the mitigation, diversion, everything?
Okay.
Without you intervening in the middle and approving any action.
I see. Okay. The same scenario with the 2T or any other scrubbing center, or you don't really care?
With the 2 Defensepro, the one.
Okay.
The
I see. I see. Okay. So for that, I need to. Just a second. I need to disable it because I can edit an active object. So it will just disable it, and it will recall a policy from the CPE. So basically, the CPE should be busy now. No policy here anymore, as you can see. And I will put it back, but as you asked, with automatic. And of course, I need to enable that flow. So it should start provisioning. So I just want to verify that the policy is here. Okay, so the policy is here. The only thing that has changed here is it's now on automatic mode, as you can see. So let's start the slower attack. Or you want me to start the flood just to see that it was?
I want to see the flood because with the slow loaders it will not redirect the traffic.
Yes. No, just want to ask you if you want to see step by step. But basically the flood will be discovered first by the CPE because there is no diversion now. So I'm flooding. So let's look at the CPE. This one is not from now. We are on 24 minutes now, so we should have a new one. And let's look at the traffic. It will be for have more visibility. So did not refresh the policies yet. Let's see. Okay, so I have an increase in the traffic here, in the connection rate. I'm sorry. This is my increase in the traffic. So let's see. It should reach above 300 megs. Let's see, only inbound, because I have a lot of outbound. Okay, so the inbound traffic, as you can see, reached the threshold already. So let's have a quick look here. It's attacked and it's active, as you can see.
Okay.
Back P. Let's see if the traffic will drop. It should drop because it now should be. Okay, so you can see the attack is dropping now. And this is because, let me open the router. I have a BGP here. You see it wasn't here before. I have an automatic action here. So this is now diverted. And the scrubbing center 1, which is the one who is responsible for diversion, as you can see, the attack is now reaching scrubbing center 1. So I can use devices policies to see the policies now. Trying to.
It's better than a magic show.
So as you can see, we saw the attack on the CPE, and now we're seeing the attack here. And the CPE should say that the attack is now over because the traffic was taken from it. Let's see, everything is terminated, nothing is ongoing, while this one is in ongoing state. So let me just finish the cycle. Let's stop this one. And let's see the traffic monitoring here. Sorry, traffic utilization here. So when vision will refresh, the traffic will drop. Okay, while we're waiting, basically I can see these events. I don't really need to run between these devices. As you can see, Defenseflow centralizes all the events. So now this one told me that something occurred, and I can see here by the device IP. You see, this one, 0.13 is my CPE, 4013, and 2012 is my scrubbing center 1. So this one started the attack, and now you can see the attack is managed by the scrubbing center. So different devices reporting different states. If I will go to the monitoring, the object is now normal. It's not attacked anymore. So basically, if I go back to the scrubbing center, the traffic is dropped, and nothing in the policy state because it was exported automatically. And my BGP, this one should be gone. As you can see, the host route is not here. So it can do everything by itself. Just wanted to show you the option of the user confirmation, of course.
Great.
Any questions?
Alejandro?
Sergey, thank you.
Okay, Sergey, so I guess we are done.
You tell me.
No, and just stop. I'm going to stop the recording.